Hello again, 4C and 3U chemistry students. So we've been looking at stoichiometry, and today we are adding another aspect besides regular stoichiometry, percent yield and theoretical yield. Today we're looking at limiting reagents. So basically by limiting reagents, just to review, we're talking about reactions where you have quantities of two or more reactants, and one of them ends up running out before the other one. So the limiting reagent always dictates how much product you can possibly get from a reaction because it runs out. It's very similar to baking. You know, the chances of you having exactly the right amounts of all your ingredients to use up everything and make your batch of cookies would be very strange. And it's the same in chemistry where, one reactant is probably, less, and therefore you're only going to make so much product. Okay, let's get started, and this will be great review for anyone who's been having trouble with stoichiometry in general, because we're going to be doing stoichiometry, just adding an extra little thing. So as I've mentioned before, I think the best thing you should do at first is organize your information under the appropriate columns. So for instance, silver nitrate, a solution with 5.1 grams of silver nitrate. So mass is 5.10 grams. We'll put it under that column so we don't get mixed up and start using that number with the wrong substance. It's going to react with a solution that contains 0.0700 moles of potassium chloride. So here we've got 0.070 moles. And if you wish, you can call that N, because that is our short form for moles. Okay, and then the question is, what is the mass of silver chloride that we're going to make after this reaction? So you should always have something with a question mark in a stoichiometry problem, because you're always being asked to solve for something. Okay, so what I want to point out is you can recognize if you have a limiting and excess reagent problem, because suddenly you're going to have quantities of two things that you know, and it will be reactants, just FYI. And of course, you'll still have one question. So because you have two things, we have to test them both out. So I'm just going to kind of number them so we keep them straight in our problem. We have to do two separate calculations in order to figure out which one is going to make us the least amount of product, and then that will be how much product we actually get. Okay, now I'm going to try to do everything in one line, so because of that I'm going to start way over here, and we're going to test out number one first. Now I guess before I go too much further, I should just do what I've asked you to do in the past, is that if you're given a mass of something, or if you're asked for a mass of something, you know that you're going to need the molar mass. Okay, so the molar mass of silver nitrate, which again right now I don't want to go through doing that. You've been getting lots of practice and most of you are doing great at that. Okay, so 169.88 grams per mole. And silver chloride's molar mass, which we're definitely going to need, is 143.32 grams per mole. Okay, now we're ready. So everything's organized in its correct columns. Notice we didn't have to worry about a molar mass for potassium chloride, because this guy we're getting off lucky and we're already at moles. So we get to not have to do an extra step of math there. All right, back to silver nitrate, or our first reactant that we're going to test out. We've got 5.10 grams of silver nitrate. And of course, we have to get it converted to moles, because that is always our first step in any stoichiometry problem. And we have said that 1 mole of it weighs 169.88 grams. Now, I'm just going to make that a little bit smaller, and I'm also going to, just so I don't have to take up so much room, I'm going to do the process I've been starting to show you, where you can just put everything in a row and then do all your math at once. So the grams are going to cancel, and at this point, maybe I'll just put my substance in here, which is a good idea. My answer at this point will be in moles of silver nitrate. But of course, I need to get into moles of silver chloride. So I look at my balanced equation, which in this particular equation, it's 1, 1, 1, 1. So it seems pointless, but it's not. You put 1 mole of silver nitrate on the bottom and 1 mole of silver chloride on top. And this step is going to allow us to change from talking about silver nitrate into talking about silver chloride, because these are going to cancel. So at this point, if I take 5.1, divide by 169.88, multiply by 1, divide by 1, I'm going to get 0.0300 moles of silver chloride. That's how many moles of product I could make. Okay. Now, I'm just going to leave that for now. We may come back to it. Now I'm going to see how many moles of product I can get with my potassium chloride. Okay, so I'm just going to leave a little bit of room. So my second substance, I have 0.0700 moles of potassium chloride. And again, I want to know how much product of silver chloride I can make. So notice we get off lucky here because we're already in moles. So I just need to use my mole ratio. So 1 mole of potassium chloride will always make 1 mole of silver chloride. Okay, so obviously we get the exact same answer, but our units have changed because moles of potassium chloride is gone and we have silver chloride. Okay, so this is what I want you to really pay attention to, is at this point, our one ingredient was going to get us 0.03 moles of silver chloride. The other ingredient had the potential to make 0.07 moles. This guy's going to run out first. So I like to just circle it, not a square, because I've been trying to get you to use squares or rectangles around your final answers. But circle it so right away you're like, okay, this is the least amount of product. Okay, so least product. And that tells you if that's the least product, that means that silver nitrate is what we call the limiting reagent, because it's the one that ran out and made us much less product than the other substance. Okay? Now, once you've determined that, this other little step was completely just for you checking and being sure, but you will not ever go back and do anything with the potassium chloride information because there's no way we're going to make that much product. So at this point, we're going to just continue our math. So we have moles of silver chloride, but we were actually asked for mass. So I'm going to put 1 mole of silver chloride on the bottom, 143.32 grams on the top. And now notice that moles are going to cancel, and I'm going to end up with an answer in grams, which comes out to 4.299 grams of silver chloride. But if we look back at our question, 5.10 had 3 significant digits. Really, that's the one that matters because that's the one we used for our answer. This happened to have 3 as well, but even if this would have been a different number, it's the 5.10 that's important because that's what we've used to begin the calculation that end up being the right one to do. So we want 3 significant digits, which means we're going to do 4.29 maybe. Look at the 9, that brings that up to a 10, that brings that to a 3. So 4.30 grams silver chloride. that is all you are going to get, because that's the ingredient that's going to run out, and therefore that is the most you can possibly have. Okay, that is it for today. Good luck with the practice problems that follow.